So I've started recording the session, and let me also open my camera just so that you can attach the face to the name. Okay, but during the session I will be disabling my camera so that we don't consume extra bandwidth during the session. So let me share my screen. I hope you're able to see my screen. Any confirmation that you're able to see my screen? Okay, so this is our first session of our IPRAN training series, and we plan to have multiple sessions. So IPRAN is a very common networking technology, especially if you are working on a service provider network, especially the carrier networks. I'm sure you've interacted with it. So we'll be having multiple sessions on how to deploy, how to design, and even how to implement IPRAN technology for the service provider networks. So I will start by just a simple introduction of myself. My name is Martin Indeche. I'm the trainer, and this session, the training is sponsored by Life Technologies. So we have a YouTube channel and a website. You can see it from the slide. If you haven't visited them, please do so. And just remember to also subscribe to the channel because we will be uploading the recorded session to our Life Technologies YouTube channel. About myself, I've been working in the service provider network for some few years. I started working at Huawei, that was in 2020, as a datacom network engineer, primarily managing Safaricom, Airtel, and even other service provider networks. And so I worked at Huawei from 2020 to 2022 in June. And then I moved to Innovis as HLS transmission engineer, primarily working on Airtel networks. Currently, I'm working as a MPBN PACO SME engineer at Nokia. For the education background, I have a master's degree in computer science and a bachelor degree in electronics and information engineering, both acquired from China. That is enough for the introduction. We move to the main topic of the day. So from the start, I mentioned that we are focusing on trying to understand the IPRAN network. So in our today's session, we'll be focusing on these items. The first thing will be giving an overview of ISP network. ISP network will be carrier network, it could be enterprise network, but we'll just give an overview because I know all of us are working in different networking environments or different service provider networks. So what I may explain may be different from what you are dealing with. But if you have something to add, if you have something to subtract, just feel free to point it out. So once we have looked at an overview of service provider networks, that is the internet service provider network, we'll now dive into the radio access network. After the radio access network, we'll be looking at the IPRAN overview, and then we'll discuss different topologies that you expect to find in IPRAN network. And the next item will be IPRAN devices from different vendors. We know we have many vendors. We have Nokia, we have Huawei, we have Juniper, Cisco, ZTE, many vendors. They produce different networking devices, and these devices are deployed in different areas of the network. So for the IPRAN, for my presentation, I will just focus on Nokia and Huawei. These are the ones that I've dealt with, but of course Cisco can also be deployed on IPRAN, Juniper can also be deployed on IPRAN, and many other vendors, ZTE, MikroTik, they can all be deployed on IPRAN. But for examples, I will just focus on Nokia and Huawei and let you know different devices that are used in different layers of the network. Then we'll be looking at the IPRAN protocol stack. So for the network to work, we have many protocol that we have to deploy. We have protocol that we need to configure and ensure that they are working okay before we can now deploy services on the service provider networks. So we'll be having an overview of the protocol that are deployed on IPRAN network. And finally, we'll have a question and answer session so that we can discuss and interact and get to answer some questions from the audience. I hope that's clear. So we move to our first item, introduction to ISP network. So ISP network, of course, it's wide, it's big, depending on the coverage. Maybe it's serving just a given. We also have the private ISPs. Maybe they are just covering a small area, and we have big ISPs. So this one is just an overview, a big picture of the service provider networks. So when you are walking on the roads, when you are out there, you always see the towers. Let me take. You see the towers everywhere in your neighborhood, on the roads, in schools, in towns. You are seeing the towers everywhere. So those are what we calling the base stations. The base stations, of course, they could be for different technologies. We know we have different networking technologies. I mean, different radio access technologies, for example, 2G, 3G, 4G, and now 5G, and even there is the new proposed 6G. So it all starts with the tower that you are seeing out there. We also have another entity here. We are calling them the enterprise customers. So once the service provider has set up the network, of course there are some enterprise customers that want to communicate. So maybe this customer has an office here, and hello, and they also have another enterprise branch. Maybe that is the HQ, and they have other branches connected to this IPRA network. So we'll be deploying services for them so that they can be able to communicate over our service provider network. So that's why I have included the enterprise customers. Apart from the IPRA network, we also have the microwave transmission. So microwave is also a very common transmission on the service provider networks. It's very common, deployed on many, whether it's Airtel, Safaricom, and many other ISPs. They all have some microwave deployed. But our focus, of course, it's not on the microwave transmission. So all these will be connecting to the IPRA network at some point, and once they are connected to the IPRA network, we are now connecting to the core network. Now, the core network, of course, will have the controllers, will have the controllers for different technologies, 2G, the BSC, the RNC, the EPG, the EPC, Evolve Packet Core, the S Gateway, PCRF. All these other nodes will be part of the SGSN, GGSN. They will be part of the core network. So we need to have an end-to-end connectivity between these nodes. And I've added another snippet here just to show you that yes, we have the core network, but again, for us to be able to connect to other nodes, we have the submarine cables. So I know you should be aware of this because we have had outages on the submarine cables and you are impacted in one way or another. So we also have another backbone that is the submarine cables, of course, connecting different continents. Hello? Please mute. So we have this part of the submarine cables. Hmm. Hello? Let me just check who is not muted. Okay, so I will continue. So we have the part of the submarine cable that is now connecting us. For example, if it's Airtel network or Safaricom network, it has to connect to other providers. It could be AT&T, it could be Vodacom, and many other service providers out there. And then we have a connection to the internet. So yeah, this is just an overview of the service provider networks in a big picture. Of course, there are many other details. There are so many other nodes that come in picture, but we'll not be diving into them for now. So on the next slide, now you can see that yes, we have starting from the starting from the user here. So we have this user somewhere in a remote location. This user could be using a phone, could be using any other device that can communicate to the tower. So we have the tower that is serving this user. Remember, we will have different towers in different locations, and these towers will be covering a given location. So when we talk of coverage, of course, we are looking at the tower that is serving the user and how many towers are in a given location. So this tower will be serving this user, and then this user is using a mobile phone. So he's connecting to the tower, of course, using the radio waves, and then he has to the data from the user has to be transported all the way from the user equipment to the internet, or it could be a call. Maybe it's making a call from this tower to another tower in a given location. Maybe there is another tower somewhere here. So down sorry, down the tower there is always a shelter. Under that shelter, now that's where you will find that we have the base transceiver station, the BTS, the E node B, the G node B, or different equipment for different radio access technologies. You can see that we have the BBU, baseband unit, and then at every site we'll also have a router. Of course, we'll dive into deep into the architecture of these routers, how they are connected. So we have different uh, layers. You can see that this is the access layer. We have the metro, we have the core, and then we have the internet. So these are just some different layers that you expect to find in a service provider. We also have the fixed access networks, the FTTH, fiber to the home, fiber to the office. They are connecting from the homes, from the residential homes, from the enterprise offices to the OLT. The optical should be the optical line terminal, and then they are also connecting back to the access router or the aggregation router in whichever location that is closer to the OLT. So these are just some different scenario that you expect from the FTTH fiber to the home to the enterprise customers, and then we have the mobile services. So remember, in this session our focus will be on the mobile mobile services only. This is another topic that, yeah, maybe it will be covered in the future for the fixed access, for example, the OLTs, the FTTH, and many other part of the many other sections of the service provider networks. So we'll have the aggregation routers connecting to the core router, and then at the end of the day they will have to connect to a data center. So service providers, of course, they have different data centers in different locations, and these data centers are the ones that are now housing the controllers, the core equipments, the BSC, the RNC, and even the caching, because sometimes, of course, you will have servers here for Facebook, Google, and many other content providers being installed in the data center. And if you don't have caching, of course, now you have to go to the internet. So this is just an overview. Another thing that we also need to get to understand is we've talked of the radio access network, and we have different radio access technologies. So of course, it has evolved very quickly in the past few years. We had the we had the 1G. You can see that someone is just walking, and then we have had subsequent evolution for different radio access technologies. We have had 2G, 3G, 4G, which we call the long-term evolution. We now have the new radio 5G, and we are also talking about the 6G. So you can see that for these technologies, they have different data rate. For example, 2G mainly, you can see that we only have 50 kbps and a latency of 300 milliseconds. So this one was primarily used for voice and text. So you can see if we have only 50 kbps, you really don't have to focus much on the capacity. Because even if you have, for example, a 1G link, it's very enough to serve many, many customers because it's just 50 kbps. But again, when you look at now 3G, 4G, 5G, you can see that 3G, the UMTS, we are talking of 21 Mbps, latency of 100 milliseconds. 4G, the long-term evolution, we are talking of 100 megabits per second, latency of 10 milliseconds. And even we are now introducing new requirements like the mobility. And when you look at the applications, we have the voice, the mobile TV, mobile internet. So now we have so many other applications, TikTok, Facebook, and many, many other applications that are coming in. And now we have many, many requirements that are coming in, and we need to be able to meet these requirements. Then now comes the 5G. We are talking of 20 Gbps, latency of 1 milliseconds. You can see the mobility requirements. And now we have many, many applications, the wearable devices, IoT, smart cities. So you see that every access technology, they have their special requirements. And as a service provider, you must be able to meet these requirements to ensure that user experience is at its best. When we talk of 6G, you can see that we are now talking of a data rate of 1 terabits per second. Latency into microseconds, mobility around 1,000 kilometers per hour. We should still be able to meet all these requirements. So why I'm talking about this is because when we start talking why we need the IPRAN, it explains the main reason why we have evolved from the traditional radio access network technologies to the IP-based radio access technology. So I hope we are good up to there, unless there is a comment, there is a question, or there is an addition from anyone in the meeting. Yes, yes, yes.
Have a question.
Just proceed to ask.
Yeah, yeah. I see the explanation that you have done. You said about the evolution from 1G up to today we have 5G and the 6G, which is not here yet.
Yes.
So I mean, without you mentioned something about they evolve, I mean, the evolution to the IP,
Yes.
so that the service can be to the IP base. So if there is no IP base, then we will have issues with speed or something like that, or delay.
Yes, you see, okay, I will be coming to that and we'll mention why we need IP. I think that question will be answered in the next few slides.
Ah, okay,
Yeah.
okay.
But you can see from 1G, 1G only 2.4 kbps. You see, when you have even a 1 megabit link, maybe the E1s or the ATM, any other, it could be able to serve all the customers. Like you only need 2.4 kbps. Even if you have many, many customers, maybe a 1G link will be able to serve that purpose. But when you move from 1G to 2G to 3G to 4G to 5G and now to the 6G, you can see that the requirements are increasing. And now we need to look at the capacity. Are we able to provide this 20 gigabits per second for the customer? Are we able to provide a latency of 1 milliseconds? You can see that, for example, 6G that is coming in the next few years, we are talking of 1 terabits per second and 10 microseconds of latency. And now the applications are complicated. We have the IoT, we have smart cities, we have the automated cars. So yeah, there are many requirements coming in. So yeah, that's why IP has been adopted by many service providers so that we can meet majority of these requirements.
Thank you so much.
Any other question? Any other comment from the team? Okay, so we can move
Yes,
to the, yes, yes,
maybe I can add something
yes.
because someone asked you something in the comment section. Is BSC or RNC considered as IP-LAN devices?
BSC and RNC, they are not considered as of course, you know, we have the radio access network. The IPRAN we are talking is radio access network, how we are able to access from the BSC, from the tower up to the BSC or the RNC. I think once we go deeper into the IPRAN topology, we can now discuss about that. Okay, I'm not able to see the comment section unless, so if you have a question, just open your microphone and ask it. But I have later I can check the comment section. So allow me to move to the next slide. So we are now starting to talk about the RAN. So RAN stands for Radio Access Network. Let me try to clear the drawings first. So we have the base station here, the BTS, the base transceiver station, the E node B, the G node B for different technologies. We now have the G node B for 5G. And then in the next slide, we, sorry, we have different controllers for different access technologies. So we have the BSC, we have the RNC, we have the EPC, and many other nodes, the controllers for different technologies. So when we are talking of the radio access network, we are just focusing on this part. From the base station to the controller. The network that is between the base station and the controller, that is what we are calling the radio access network. So the base station definitely will not be part of the IPRAN network. It's part of the RAN network. So another name that we can call this radio access network, we can call it the base station backhaul network. And it's the transport network that is deployed between the base station. So in base station, I mentioned that we have different access technologies. The BTS, it's for 2G, node B is for 3G, E node B is for 4G, and then we have G node B for 5G. And then the base station controllers, the BSC, the RNC, the EPC, the 5GC. So this is just the network that is being deployed between the base stations and the controllers. That is what we are calling the radio access network. And traditionally, of course, before we had the IPRAN, we have had different,
Brother Martin,
yes, yes.
okay, is it allowed to ask a question when you just mentioned about something?
Just 1 minute, give me a minute, just 1 second. Yes, you had a question?
Yes, yes. I see you said BSC is for 2G and RNC for 3G and for 4G it's EPC.
Yes.
And what about MME and SGW?
You see the evolved packet core, it's evolved packet core because when we are talking of 4G, we have the evolved packet core, the EPC. The EPC will have different other nodes, not just the EPC is just a representation of many, many other nodes. It's the evolved packet core. So we could have the MME, the S gateway, the BP gateway, PCRF. They should be both part of the EPC.
Okay, okay,
Yes, you see,
okay,
when we are talking of 3G, we have the GGSN, SGSN, many, many other. Of course, we have many, many other nodes that are part of the different radio access technologies.
okay,
But yeah,
okay. Thank you.
yes, yes. Any other question or comment before we continue? So, the traditional runs were mainly constructed using the TDM, time division multiplexing, or the SDH. The E1s, okay, I have not interacted with E1s myself, but the frame relay, the ATM, but those technologies were limited in terms of capacity. So we, as you've seen here, I've mentioned that for 1G it was very okay. That is 2.4 kilobits per second. But when you evolve into the newer access technologies, you have higher requirements in terms of capacity, in terms of the latency, the mobility, and even the applications. So one main disadvantage of these traditional runs was the capacity that they were offering. Maybe you could just have an E1 doing, I don't know, 2.5 megabits or something like that, or so they are limited in terms of capacity. But now when we are evolving to IP, we can do higher capacities. There are networks that are doing 800 gigabits. There are those ones that are doing 150, 10G, depending on the capacity of the network, of the service provider networks. But here the key highlight is the radio access network is just the transmission network from the base station to the controllers. So that is what we are calling the radio access network. So now we look at the IP. So when we talk of IP, of course, we know the IP stands for Internet Protocol. So we have the radio access network that is based on IP. This is what we are calling the IPRAN. We are using IP as the transport layer technology. So you have your base station here, you have your controllers. Now instead of using the SDH or TDM or many other those all technologies, you deploy IP network in the middle of these nodes. So this is what we are calling the IPRAN.
Sorry, Brother Martin,
Yes.
can you just say it again about the IP, what you just mentioned now, concerning the IP RAN network, TDM and stuff. Yeah.
Yeah, I've just mentioned that the challenge with the traditional SDH, TDM frame relay, it's on the capacity and also the cost of operation, which is very high. So we now introduce what we are calling the IP network. And now between the base station to the controllers, we are deploying IP based. So IPRAN is just like it's the radio access network that is using IP as the transport layer technology. We are not using the TDM
Okay.
anymore. We are not using SDH, the E1s anymore. We are now purely running
Okay.
on IP.
Okay.
So with this one, IP is now replacing. Hello? IP is now replacing the old one. Lisha, please mute. Sorry for that. Please keep your mics muted if unless you're asking a question. So we are replacing the older TDM or old transport technologies with IP.
So sorry, Mr. Martin. I want to ask you something.
Yes.
Hello. Yeah, you are referring.
Martin, I think you are controlling this meeting. You can just mute this guy and
Yes, I've muted him, but he keeps unmuting again.
he is not aware what we are doing here. It's weekend.
Was it Elisha who was asking a question?
No, it's brother Peter. It's brother Peter asking.
You can remove Elisha from the meeting. I think maybe he's doing some other stuff.
Yeah, he it seems like he's in a party or something.
Yeah, you can just
Okay,
remove
Peter.
it.
And you guys are
Yeah,
in a very serious meeting here. Even talking out there.
yes, Mr. White. I see like you are referring radio access network as the party from tower to these controllers,
Yes.
but from my understanding, LAN network is from now the tower to the end users. That is the one I refer it as LAN. But for you, I see like you are referring the network, actually the transmission part from the base station to controllers as a LAN network. Is that correct? Because from my understanding, I know that the LAN network is from the tower now to the end user, like the mobile users.
I think Martin was trying to explain the interaction between the RAN and the IPRAN. Now, on the RAN layer is now the radio controllers and the nodes. But where does the IP come in? Now he's trying to look on the access layer. I think that's why he described the picture of the RAN and where he's drawing the IP network.
Is that clear, Peter? Of course, depending on when you are talking of are you talking of the LAN, the local area network, or I've heard you mention about that?
No, radio access network.
The radio access network.
Yes, because for you are referring it as from base station to controllers, but that's the part of transmission of which now the IP LAN come into picture. But for me, I know the IP, the LAN, actual radio access network, is from the tower to the end user. So from the tower to the end user, that is one which we define as radio access network. Where now the 4G, the 3G, that particular part, and the end user are using those technology to actually to do as communication, blah blah. Yeah.
You see, when we are talking of course, we have the radios which are on the tower, the base stations, and then we have the controllers. So it depends on how you take the radio access network. For me, the radio access network is we can put the user in the picture and make it like from the user to the controllers, because the controllers are still part of the radio access network.
Yes, I see. Okay. Can you proceed?
Yeah, so we have mentioned someone still not muted. Okay. So for me, my definition of the radio access network is all the way from the base station to the controllers. Of course, we have the users behind the base station, which are trying to access the resources from the controllers. So that is why we are bringing in the IPRAN, the transmission network between the base station to the controllers. We call it the IPRAN. So the main advantage of IPRAN, I've mentioned it's on the capacity. Remember, IPRAN, we can run it over, it could be even microwave. Nowadays, we have 10G microwave that can do even 10G capacity. We have a DWDM. And this IPRAN, of course, IP will be running over, it could be microwave, it could be DWDM that is offering very high capacity links. 10 Gs, 100 Gs, 200 Gs, depending on the capacity that you want. You can be able to do it with the IP technology compared to the traditional transmission like the E1s, the frame relay that were limited in capacity, and also they were too rigid. When you are deploying them, the deployment will be complex, even complex to manage. But now with IP, it's very easy to integrate, it's very easy to manage, it's very easy to deploy and even expand the network to higher capacities when you have IP as you are the radio access network or the radio transmission network. So I hope we are together there. We'll be moving to the next slide. And now from the
Brother Martin?
yes.
Yeah, sorry. So with TDM, there was not a way to make to have a bigger capacity.
TDM. Okay, I haven't really personally. I haven't interacted with the E1s, the SDH, but when you read about them, definitely you couldn't have the capacity that we are having currently. Like the DWDM, you see, we are doing around 800 G, even terabits. We are doing 200, 400 in the metro. For the TDM, the SDH, the E1s, I've never encountered such high capacities. But of course, you
Okay,
can
thank you.
research about them and get to know more about these older technologies.
Okay, thank you. No. It's not about to know about them. Just the reason why. My
Yes,
point is to get the point of the reason why we have now IP in RAN network, so that we can have a bigger enough capacities
enough
to provide
capacities,
to
easy to
customers.
deploy. Yes, so we are even having reduction in the operation cost. IP, it's very easy to deploy. If you have worked with IP, I'm sure, I mean, if you have worked for IPRAN networks, especially on these big service provider, you realize that they are very easy, very flexible, and even easy to manage compared to these
Thank you.
other traditional technologies.
Thank you.
Okay.
Yeah, it's like
Yes.
it's all about capacity. Like we move from electrical to fiber.
Yes. Okay, to the next slide now we are discussing the IPRAN component. So
Hello,
yes,
hello, Martins.
yes,
Sorry to interrupt there. Yeah. Okay. I was getting a little curious when it comes to. I've been thinking of how the transport network would be like in the IP RAN system because I've been a field engineer for years. But in years past, I moved sector out of telecoms.
yes,
So I lost along the way, and when I came back now recently, I made the IP. So
yes,
I've been wondering what sort of equipment is going to be the transport system equipment, because all I used to be used to then was PDH That's what we used to transport the E1s from side to
yes,
side down to the BSC
yes,
and co. So, but from your explanation now, okay, I was thinking, it's a different type of radio. But I see now it's almost the same. It's just that it's a much higher capacity type.
yes.
Am I right?
With IP, of course. Hope I've not interrupted your question.
No. Go on.
Okay, because with the IPRAN, we are purely, you see, we are now using the routers and switches and even a mention of the WDM. So the routers and the switches are now able to give us higher capacity connections to all these other equipments like the DWDM, and we end up having higher capacities. So the IP network, of course, it's more of the router and switch solution. We have the routers, we have the switches instead of those equipment that you have mentioned that were used for SDH or the E1s.
Okay.
Yeah.
Okay. Very clear now.
Okay. So when we talk of
All right.
I,
Thank you.
okay, when we talk of the IPRAN technology, IPRAN,
Brother Martin,
yes,
sorry, someone want to ask a question, or maybe if he can ask first, then I will go.
yes, yes, you can ask.
Just want to get it once and for all. So that means the main purpose of we have IP run into we have IP in RAN network because of capacity issue, capacity advantages, right?
Yes, that is the primarily
Okay,
reason why we have the IP technology being
okay,
deployed on the service provider networks.
okay.
Primarily
Thank you.
reason it's for the capacity, but we have other reasons like in terms of cost, in terms of ease of deployment and ease of management. Okay,
Okay,
so
thank
we
you.
move now to the IPRAN component. So we have been talking about IPRAN
I'm
as a,
sorry, Martin.
yes,
Uh, uh, I think you really need to do the introduction about like the speed, latency, and all those. Like otherwise, you'll be going back and forth, back and forth.
okay, in terms of speed, of
Sorry.
course, I've mentioned, like you see, with the IP, we are able to have like the 10G, 100G, 200G, even 800G. I'm aware of even service providers who have even deployed links that can do terabits or much, much higher capacity. So, of course, with the IP, we are able to achieve the higher capacities. I'm sure if you are managing a service provider network currently, maybe the minimum link that you have could be 10G in your IPRA network. 10G, 100G, 50G. Nowadays, we are upgrading to even 100G in the access layer. So the main focus that we are talking about is, of course, we have from this slide, you saw that these different technologies have different requirements. And this, for you to be able to meet these requirements, definitely the first thing that you want to have is higher capacity links, right? Because if the user is pushing 1 terabits of data and you are only giving him a 2.5 gig or something like SDH or the E1s that maybe could do a maximum of 1G, you see, you are not helping the user. The user experience will be very bad. So you need to be able to give the user higher capacity link for them to be able to download or upload the amount of data that they are pushing to the internet. So when you talk of these icons, you can see like from the icons clearly showing the different speeds that we are using. You are walking, you are just running, you now have the bicycle, you have a motorcycle that is now faster on 4G because yes, you have higher capacity, you can push more data that is, and even less latency. Then you are now using the plane, you are using the rocket, and when you are using the rocket, definitely you are pushing 1 terabytes of data. You also need to have a higher capacity link that is serving you. So even for the FTTH and all these other applications, if the user is pushing more data, then definitely he has to purchase higher capacity links.
Great, noted. Thank you.
So moving to the now the IPRAN component. So we have been talking about the IPRAN as a black box. Just mentioning that we are turning from the access from the radio to the to the controllers. So we have different components that make up the IPRAN network, and this is the general topology. You can see that we have the RSG. RSG, we call it the radio site gateway. This is the node. This is the big router that is now connecting to the BSC and the RNC, the radio controllers in the network for different access technologies, whether it's 2G, 3G, 4G, or 5G. And then we have the aggregation site gateway. So we can just, this is the standard architecture, but of course there are some special scenarios. So let me first explain the standard architecture, then we can now move deeper and see other scenarios that we have that are available on the service provider networks. So we have the RSG. I've mentioned this is the radio site gateway. This is the core node. This could be the bigger router in the network, higher capacity, higher processing power, and even in terms of port density, it will have many ports because you need to connect to different other nodes. Then we have the aggregation site gateway. So the aggregation site gateway, this is now aggregating the traffic from the access. So this is a good example of the aggregation router. You can see that they are now aggregating traffic from the access. That's why we are calling them the aggregation site gateway. So they aggregate the traffic from the access. All these access nodes will be connecting to either of these ASGs, and then of course we also have these SGs connecting to other aggregation routers, and finally they will connect to the radio site gateways, and finally connect to the controller, the BSC, the RNC, the MME, and many other controllers. So on the access side, every site will have a CSG, what we are calling the cell site gateway. So with the cell site gateway, now this is the device that is connecting directly to the BTS at site. The BTS, the G node B, the node B, or the E node B. So this is just a small router, a very small router, not bigger, not same as the ASG or the RSG. It's just a small router that you need to connect to the BTS, maybe using, many times we do 1G connections or 10G connection from the CSG to the BTS, but from the CSG to the ASG, this one, we make the minimum of 10G. Nowadays, we even have a connection of 50G or even 100G, depending on the network capacity requirements. So the CSG, this is the access router. Every tower, everywhere you see a tower, definitely we will have a router down there that is now connecting to the BTS. Of course, sometimes we have the microwaves that is also allowed, but for the standard IPRAN architecture, we have the RSG connecting to the ASG and then ASG connecting to the CSG. And you can see from this topology that they are forming a ring. So we have a ring of CSGs connecting to the ASG. We have a ring of ASGs connecting to the RSGs, just for redundant reliability of the network. So we have the CSG, ASG, RSG, and then we have the controllers. So these are the main components of the IPRAN network. Any question up to there?
No, Brother Peter. Sorry. Brother Martin.
Yes.
Sorry, I mistaken with one of my brother, Peter. The name. I just want to get it again properly.
Yes.
So the idea behind the rings between CSGs or ASGs is just about redundancy. If one CSG is down, then the other one can take over. Is
Yes,
that
yes, that is the
correct, or
primary.
maybe?
That is the primary role of having the ring setup. But in the next slides, we also have to discuss different topologies of IPRAN. So yeah, we will address it much deeper in the next few slides.
Okay.
But the primary role is for the redundancy of the network.
Hello,
Thank you.
Martin.
Yes,
Yes, so I wanted to ask, so
yes,
whether a site is doing 2G, 3G, 4G, they will all still connect to the CSG, correct?
yes.
Okay.
And okay, in this diagram, I've just used the standard topology, but nowadays we have the SRAN solution. So you see, you have different nodes, like you have the node B, G node B, E node B, BTS. Nowadays, all these nodes are in one box, and we only have one connection to the CSG. So at site, you don't expect to have like 10 connections from different radio access technologies to the CSG. You will just have one connection from there, from this box, and this box has the capacity to handle both 2G, 3G, 4G, 5G, and even the newer 5G, because some of them nowadays they are software based. So you don't have separate boxes handling different access technologies. So many times you'll find that we only have one connection from the cell site gateway to the BTS. That is it.
Okay.
Okay, Brahmatin,
Just
Brahmatin.
Yes, yes.
I want to ask that the CSGs are directly connected to the BTS sites, or there is any other microwave devices or something else?
Yes, apart from connecting to the CSGs, of course, sometimes we have the microwaves. We have the microwave equipment at site, or we have a chain of microwaves. So this microwave will also end up connecting to the CSG at some site, right? So this CSG at site will first connect to the local BTS, the local E node B, the local node B that is on site. And then it can also connect to other nodes that are behind it. For example, if you have a connection, you see this one is in a ring setup. So if you have this CSG and this CSG, definitely you will have another connection between these. But for the radio site connection, definitely we'll have a connection to the base transceiver station at site. And these microwaves will definitely also have connection to the other towers or the other base stations in different locations. So we'll be aggregating traffic from the microwaves. We'll be aggregating those traffic on these CSGs. So yes, we could have other connections apart from the connection to the BTS.
Okay, dear. And for these CSGs, can we provide redundancy through these microwave equipments, or no?
Yes, that is an implementation that is common, very common. You can have a CSG that is a router at site. You can also have a microwave equipment at site. So if you have a microwave equipment here and you also have a microwave equipment here, you see we can have redundant connection. This is the primary link via fiber connection, the IP connection, and then we have another link through the microwave. So we can provide protection through the microwave link. That is true, and it's
Okay, dear.
possible,
Okay.
and it's very
Thank
common
you.
on service provider networks.
Hello, hello. Yes,
Yes, yes.
Dija. Uh, what's the difference between NMS and MME? What's perform the
Okay, I've added the NMS because you see, once we have deployed this IPRAN network, we need to be able to manage it. We need to be able to remotely log into the nodes, see the alarms. We need to be able to get the reports on utilization and many, many other details. So there is the NMS, Network Management System, that is primarily in charge of managing these nodes, the IPRAN
thank
nodes.
okay, okay. Thank you, teacher.
Yes.
Martin, sorry, I have another question.
Okay.
So typically, NMS is purely O&M, right? We
Yes,
can lose
yes.
connectivity to NMS, but we still have the data, the traffic moving
Yes, yes,
very well.
yes, yes.
And then another question from a
Yes.
design perspective, the ASGs are normally now situated for traffic exiting like a region or something. How is it put? Like, can we have like in a district several ASGs, or it's just now since the aggregation, it's exiting traffic perhaps like within a region or something?
No, no. We can have, if you have, let me go to, You see, when you have, let me say this is one region, you also have another region somewhere. In these two regions, you can have multiple aggregation nodes. Remember, IPRAN network, especially for service provider, if you managed it, you will realize that we can have more than 10,000 routers. In one region, you can be having maybe 300 routers, even more, even 3,000 routers in one region. And all these regions, all these 3,000 nodes, will not be really the best practice to have them aggregating only on two aggregation nodes, right? So many times we have multiple aggregation nodes in one region or one cluster. And these aggregation nodes are now connected to multiple access nodes. And then we will have a connection, of course, from one region to the other. Now it could be via multiple SGs because, of course, you need redundant connection between the regions also. But you can have multiple aggregation nodes in one region.
Yeah, so the reason I was asking, because
Yes.
I've seen like the CSGs are in more of like a ring,
Yes.
like from what you've mentioned. The ASGs, do they also work in a ring-like
That
structure
should
also for
should be
redundancy?
the yes, that should be the setup. The SGs should also be
Okay.
in a ring so that they are protected. Even the RSGs, you see, basically what we normally have, like this one, all these nodes will be just in one region. So you have your aggregation, you have your RSGs, which is in one region. You have multiple SGs, you have many CSGs. This could be the network for one region.
Okay. All right,
Yes.
thank you.
Hello, Martin.
Hello, Martins.
Yes. Yes.
Okay, just to make it clear, from your explanation, that means it doesn't necessarily mean that CSGs are co-located in the BTS sites. It could be located remotely and then linked with the BTS.
No. Many times, many scenarios is these CSGs are always located in the same location with the BTS.
Okay,
Yes.
okay, okay.
Unless there will be a fiber connecting this local CSG to another CSG or to another aggregation node. So
All
whenever,
right.
from what I've seen so far, anywhere there is a tower, there will be either there is a microwave equipment if you are using microwave, or there is a router, the CSG, that is connected to the BTS.
Okay.
Martin.
All right.
Yes,
Just for clarity,
yes.
these nodes, node B, G node, and E node B, uh, can it be bundled in from a connection to an IPRAN to a BBU? Is that the same? Like a bundle carrying 2G, 3G, 4G?
Yes, yes. I've mentioned, like, you see, nowadays we have the SRAN solution. The SRAN solution will have one hardware here, and this hardware will have partitions for 2G, 3G, 4G, and even 5G, like the baseband units, and then we have one connection to the CSG.
Okay, great.
But
Thanks.
traditionally, you needed
Mm.
multiple connections. You will have a connection for 2G, you will have a connection for 3G, you will have another connection for 4G. But nowadays, we only have one connection to the BTS, and then now it handles the rest. It's able to serve different access technologies using the same connection that we have. And what we do, of course, we now configure. When we are configuring this ATN or the CSG, we are making it in a way that we are using the VRFs or the VPN instances for us to be able to isolate these different services.
Oh,
The,
okay. Thank you. Much better understand.
Okay.
Yeah, I think Martin, they are referring to when you say the transmission for the baseband. For the baseband transmissions for 2G, 3G, and 4G, they are still the same. The CPRIs are still connected to different processing boards. Yeah. But
Yes.
for the main transmission to the IPRAN, now we use the SRAN. Now we
Yes.
only have one board, call UMPT, for example, for Huawei to do the transmission and the modulation for the 4 different technologies or 5 different technologies using one cable. So we'll segregate the service now based on the IPs and the VLANs.
Exactly.
Correct.
That is a very clear explanation. Thank you.
But
I
Martin,
wanted.
Yes,
Okay.
yes.
Yes, yes.
no,
Um.
she can go ahead. I'll ask after.
Okay. My question is like, is the DWDM technology now considered to be in the aggregation layer, the one that now aggregates the signal from the SG and becomes a link to the now RSG? Is that
Yes, yes.
what that
Now,
is?
Yes.
please mute.
Uh,
There is echo. So, okay, thank you. So for the DWDM, we are now using DWDM to connect these nodes. You see, like we need a connection between CSG and ISG. We need connection from SG to another ASG in a different location. We also need a connection from ASG to RSG in a given location. Now, this is where we are using the DWDM. So we'll have a DWDM equipment also in this location that is now able to handle the DWDM connections. I hope that is clear. So the access
Clear? Thank you.
evaluation will be running on top of DWDM if you have it deployed in your network. If you don't have, then yeah, there is always these normal fibers, the leased fibers provided by different providers that you can lease and have the connections. I hope it's clear.
Yes.
Hello, Martin. Hello,
Yes.
Martin.
Yes.
So you mean the WDM will be in between SSG and the SG and the SG to RSG, right?
Yes, if you have the WDM equipments installed, you have the WDM in these sites. Yes, many times we are using the WDM. If you have it, if you don't have it, you can use the normal. You see, the WDM gives us the higher capacity. Like if you want 200 gig, 100 gig, or even if you are aggregating different services, because you see the power of the WDM is on the modulation of different or multiplexing of different services into one link, and then it can be able to transport. So many times you will find that this connection from CSGs to the ASGs, ASGs to the RSGs, or between the ASGs and other ASGs in different locations, we normally use the WDM if it's available, that is.
Okay. So how about the SG? It is we are using the media to be the connectivity of this router IPRAN.
Which one?
I mean SCG. SSG, I mean SSG.
The connection between
Yeah.
which equipments?
We are using the media, either ni microwave or fiber to be the connectivity between.
The CSGs.
Yeah.
No,
It's fiber. It's
it's
fiber.
fiber. Yes, yes, we have fiber connections. But of course, you
Okay.
can have microwave, but fiber is the most recommended and most used solution.
In terms of capacity.
Yes, yes.
Okay.
Any other final question before we move to the next slide?
Yes, just one.
Yes.
Okay, but Martin, I just wanna get some clarity on the regions between CSGs.
Yes.
So the redundancy solution, it is on the CSGs or on the tower BTS.
Okay, let
If
me
one
move to
BTS
the
fails,
allow me to move to the next slides. We talk about the topologies and then we can now get a clear understanding of that. Okay.
okay, thank you.
So moving to the IPRAN topologies, you know that once you have a remote site in a very remote location, at the end of the day, you need to be able to connect from this remote site. You need to be able to connect to the controller in a given central location, in a given data center. So of course, you can have a direct connection all the way from all the remote sites. You run your fiber to the controller location. So you have 1,000 sites. You can run 1,000 connections from different remote location to the controller. But you see, this one is not possible. So when we talk of different topologies, we are just talking different topologies in terms of connections between these different nodes, the CSGs. So these one are the sites are the CSGs. The sites, these are the CSG equipment. So the first topology that we have, and a very common topology, it's the star or the SPA topology. So you can see that we have an aggregation node here. This one could be an aggregation node. It could be another CSG. So this one could be another CSG here, and it's connecting to other multiple CSGs. You see, we also end up having the star or the SPA topology. Or it could be an aggregation node, the ASG. It's connecting to multiple CSGs. So this one we also call it the SPA or the star topology. A very simple, very easy to set up. But the main disadvantage is we are having a single point of failure. You have all these nodes depending on this aggregation node. What happens when this node is faulty? When it fails, you end up being impacting. All these other nodes will be off. The services will be down. So we have a single point of failure when we have the star or the SPA topology. But it's very easy to set up, especially when you have nearing sites, and easy to manage. That is the star or the SPA topology. Next, we have the chain. So you have an aggregation node here. This aggregation node is connecting to a chain of other CSGs going to different locations, different directions. So this is the chain topology. Of course, it's still easy to set up when you have nearing sites. It's easy to manage, minimal cabling, because you just need one cable between the sites. Just run a cable from here to here, one cable, you have the connection. And it's also easy to add additional nodes on the edge. So if you are adding a new node at the end of this chain, you see it's very easy. You just do the cabling, you have the accessibility to this device, you do the integration, that is it. But what if you are adding a new site at this location? There is a new site here. For you to be able to insert this new site, it means you need to break this fiber. And when you are breaking this fiber, you will be impacting these other sites. So we still have kind of a single point of failure. If we were to lose this fiber between these two nodes, we are impacting all these nodes that are behind this node. So we still have a single point of failure, especially in large networks. So it's still not ideal for large networks. Because remember, the aim is to have a redundant network where you are not always having to do some manual intervention for you to restore the services, or when there is a fiber cut or the device is faulty, you end up having to wait for the device to restore or the fiber to restore for you to be able to have your services up. So these ones still have a single point of failure. Now we have the most preferred topology, which we are having the ring topology. So with the ring topology, you can see that these CSGs are connected to form a ring. Site 1, Site 2, Site 3, Site 4, Site 5, and then they are connecting back to the aggregation node, SG1, SG2. This SG1, SG2 could be in the same location. It's better if they are in different locations. Because if these two are in the same location and maybe we have power outage in this location, you see, we still end up impacting all these services. But when you have them in different locations, if we only lose, let me use a different color. If we are only having power issue here, the services should be able to switch and go back to this SG2 in a different location. So this is the most scalable solution. It's the most redundant solution. It's still easy to manage, no need for manual interventions, because whenever you have a fiber cut, a node faulty, you can always switch traffic from one side to the other. So when we lose this connection here, the traffic from site 2 can still come back to SG2. Traffic from site 1 will come back to SG1. And the only disadvantage of this is the high cost to set up. Remember, you need to have connections all the way. So of course, you need to invest more in the fiberization, having the fibers, having the connections ready, so that now you have the ring set up. So this is the most preferred topology. Let me just move a bit and connect to power. And it's the most preferred topology for the service provider networks because of its scalability and the redundant nature of the ring setup. Now, the most common topology is the hybrid topology. So with the hybrid topology, we are now having a mixture of the star, the chain, and the ring. And this is the most common on many service provider network. This is what you will find. Of course, the target is to get to the ring topology for everything, but it's never possible. So we end up having star topology. We have some sites in chain. We have some sites in rings. So at the end of the day, we end up having a hybrid topology for the service provider IPRAN network. So to answer the question about the redundant nature of the rings, I think I've explained it clearly in this slide. Unless there is
Yeah, Martin.
Yes.
Yeah, so the explanation is nicely done, but I'm
Yes.
having a little bit of a challenge trying to understand the symbols. I see all of them like symbols for routers. I can see the ASGs looks a bit bigger, but on your next slide, the one which is hybrid, can you go to it, please?
Yes.
Now there, which one is the RSGs and the ASGs? Like I'm having
this one, you see, we have this one will be the aggregation nodes.
the ASGs,
The ASGs or the RSGs.
Oh, the RS. Oh no, the RSGs, right?
The ASGs or the RSGs. Okay, I haven't really, because it's more of just how things connect, so I haven't really put them in a way that which one is the ASG, but you can take this one, the main ring. This is the aggregation nodes.
Okay,
And
okay.
you can see for them, they are also forming an aggregation ring. And from the aggregation ring, we now go deeper into now the access rings. And from the access ring, we could be having the star, a chain, the rings, and many, many other different connections.
Okay, it's fine. Thank you.
Brother Martin?
Yes.
Okay. You just mentioned something about the ring topology.
Yes.
You said that normally for better availability regarding the design, the ASG must be placed in a different location. ASG1 in different location and ASG2 in different location.
Yes, yes.
So that if one ASG at a located place is having issue with power, the other one is going to be safe to provide the network connectivity.
Yes, 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 exactly.
Okay. Okay then. So now, so the main question which I did ask is just to create redundancy between CSGs. If one fails, the other one can provide the IP transmission from the BTS to the controller.
Yes.
Okay.
But you see, it depends
Okay.
on what is failing. If, for example, we have this site has power issues, I mean, and of course, this site has connection to the BTS at the local site. So when this site has power issues, we only impact the local site. We are only impacting the BTS that is connected to this CSG. That is when you
Yes.
have node faulty. But when you have fiber cut or fiber failure, then you don't need to do anything. The traffic should be able to switch because this device is still working okay, this device is still working okay. They can still forward the traffic using the redundant path.
Okay. Okay.
Yes. So
Okay.
this is the
But
IP
when it comes
topology.
about
Yes.
faulty device, then the local BTS will be affected. But if
Yes,
it's
yes.
fiber, then the traffic will be switched to another link, to
Yes.
another ASG's
Yes, yes,
transmission. Okay.
yes.
Okay. Thank you.
Okay. So we've talked about the topologies. I hope that is clear, unless we have a question on the topologies before we move to our maybe the second last item. So I've mentioned that all these vendors, Nokia, Huawei, Juniper, Cisco, they all have devices that can be used in different sections of the network. So when we are talking of CSGs, which device can you use as a CSG? Which device can you use as a RSG or ASG? So that is what we are looking at this moment. So when we talk of Nokia, we'll just go straight to the equipments. So for the access devices, of course, I've just picked a sum of the devices. They could be having many, many other devices that can be deployed as access devices, but I've just picked the one that I've interacted with. So for Nokia, we have what we are calling the IXR, the interconnect routers. So these are the routers that are deployed as the CSGs when you are building IPRAN network using Nokia equipments. So IXR, it stands for interconnect router. And we have this 7250 IXR. So we have different series of IXRs that you can use to build your IPRAN network. And you can see that these IXRs have different, the series have different features. For example, the IXR-E, you can see that we have two QSFP, which means you could do 200G, 250G. You have 8 SFP, you have 24 SFP plus, you can do 24 10G ports. And then we have the XRE that only has 14 SFP and 4 RJ45. We have the 7250 XREC. This one you can do 610G, you can do 21Gs, and then 4 RJ45 connectors. So these are the devices that you expect to find on IPERA network in the access layer where we are using Nokia as the vendor. For the aggregation nodes, we normally use the 7750. We have the SR2S. This is the overview, the chassis overview of 7750 Nokia SR2S. And you can see that this one now, it's a modular router. These one, they are just compact units. When you go back to the slide for IXRs, they are just compact units, very small, 1U, small boxes, not modular. But when you come to the aggregation nodes, these are the devices that you expect to find in the aggregation, both ASG and RSGs, when you are using Nokia devices to build your IPERA network. So this is a modular router. You can see that we can have different cards. We have the line cards, we have the power modules, we have the fan. When you check the rear view, you can see that we have the power shelf, we have the fan modules. multiple of them. So this one you can remove the fan and then do the cleaning and return it. You can replace a power module. If it's for the primary card, the module, when you check the front view, you can replace a line card, you can replace the control card. So this is the main advantage of having the modular chassis. You can always increase the capacity. If you want another 100G card, you can add another 100G card. So these are the two devices that I'm using as an example for Nokia devices, the IXRs for CSGs and then the 7250 SR2S for the aggregation nodes. This one can both be the ASG and the RSG. And the main reason we normally use, you can imagine if you, the price, even in terms of pricing, the IXRs are slightly cheaper, even more cheaper compared to these modular routers. So if you are building a network and you want to build using the 7750, even in the access, you see, you need lots of capital for you to be able to do that. That's why many times we go for the low capacity, because these are XR, these are low capacity routers, provided they can do layer 2 and layer 3 routing, that is it. We only need few connections, maybe 1 or 2 connections, that is it. They will consume less power. So that's why in many times we have different services for the access and also for the aggregation. For the aggregation, we have many connections, so we need a device with higher port density. We need a device that has higher processing power, a device that can be able to handle switching and routing for lots of traffic that is coming in from the access. And even we have higher capacity connections, 100G, 50G connections that can be used to aggregate the traffic from the access side. Moving to Huawei. So Huawei also has different devices that can be used for the IPRAN, starting with ATNs. Many times we have the ATNs, different series. We can be having ATN 910D. This is almost similar to the IXR that we have seen. It's also a compact unit, a 1U unit. We have also ATN 910C, we have 910B, and many other series of ATNs that will be able to use on the access network or the access layer of the IPRAN network. So these are primarily used as the CSGs when you are building a network for Huawei. Of course, there are other options not mentioned here, but they are not just limited to the ATNs. There are many other options when it comes to when you are building a network using Huawei. When we talk of the aggregation, so for the aggregation, Huawei also has many other different devices. We have the Net Engine, for example, the Net Engine 8000X4. We could have Net Engine 8000M8. We have CX600. We have PTNs. So sometimes you will find that a service provider can either choose. You have the ATNs in access, and then you have the M8 in aggregation, or you could have the CX600 in aggregation. You could have PTN, different PTN versions, either in access or aggregation. So the choice of the devices purely depends on your goals, your requirements, your network requirements, the capacity you are trying to achieve, and many other considerations that you need to put in place when you are deciding the devices that you need to use. I hope that is clear. And now
Yes, it's clear.
we are moving
Yes,
to
very clear.
okay. I hope I've answered your question. You were asked which devices to use in different CSGs, ISGs. I hope that is clear enough.
Hello?
Yes.
Yeah, in some network, unlike Huawei, in some network, they are using, in the aggregation side, they are using SPE or
Écrit
something.
d'abord, hein? Écrit d'abord ce que je t'ai dit.
Hello?
Yes, I can hear you.
I said in some network of the
Yes.
world, on the access side that connects to the BTS, the LAN
Yes.
side. Normally they call it UPE And then the aggregation side, they have the SP, and some bigger network can also use NPE.
Yes.
So
For me, I just call them the semantics because when we talk of, we'll have a session on the HVPN solution. So when we talk of the HVPN solution, that's when now Huawei uses those names of the UPE, the SPE, the NPE. Yeah, and it's correct. Of course, the SPE will just be the aggregation node. The UPE will be the CSG, but same functionality, right?
okay, okay. So which means in Huawei, the CSG is like the SPE in other
No.
network, for instance.
When you are
Only
talking,
for
yes, yes.
is it only for HOVPN scenario or for a normal scenario where you don't have HOVPN?
Depending on different technologies, when you talk of the different, because Huawei, for the standard Huawei solution, it still calls the ATN the CSGs. But when you talk now about the hierarchical VPN, that's when it's bringing in the idea of the UPE, NPE, and SPE.
Okay, okay,
Yeah,
I
because
get you.
now you see the UPE is still the user and device, which is now
Yes.
the CSG in this case.
Okay.
Yeah. So it's just the naming conventions will from different
Vendor.
vendors. Yes, yes. But still, it
Okay,
means the same thing.
okay, okay.
Yeah. Finally, second last slide, we are now talking about the IPRAN protocols that we expect, the IPRAN protocol stack. So when you are setting up a network, of course, the end objective is to have connectivity between different sites or to have communication. We say, do you need to have communication all the way from the user equipment to the controller? And for us to be able to achieve this, we need to be able to deploy some protocols on the network. So yes, you have the physical connections, you have connected your routers using different topologies. That is not enough. You cannot start deploying services on this network. You still need to go ahead and configure some protocols on top of it for you to be able to now carry the different services. So we have many protocols. This is just a mention. Of course, in future we'll be having a session to now dive deep into, especially the IGP and BGP. We'll have separate session to discuss IGP, EGP, and even segment routing. But in this session, we'll just give a quick overview of the protocol that we are using. So for IGP, we normally go with ISIS or SPF or EHRP. If you have Cisco, of course, you can go with EHRP. RIP, rarely used, but many times it's either ISIS or SPF. But later we can dive deeper into these protocols. For BGP, we have mentioned that the IPRA network, we are segmenting it into different regions. So we need the border gateway protocol to be able to now interconnect these different regions or these different clusters and have end-to-end communication or connectivity between the different clusters or the regions. We have the multi-protocol label switching. I know this is a very common switching protocol, a layer 2.5 protocol. Many times, given that we need to deploy VPNs, we need to go with MPLS, though BGP, MPLS, ISIS, LDP. If we are using MPLS, you need to be able to distribute to distribute labels. So we have LDP and RSVP. These are the two signaling protocols commonly used. Of course, nowadays we have segment routing that is also used as the signaling protocol. We have quality of service. So when you have these different radio technologies, 2G, 3G, 4G, they all have different requirements in terms of latency, delay, capacity, the bandwidth. So you need to be able to deploy and design proper QoS so that you ensure all these services are able to meet their requirements for the custom experience. Then we have the DCN, the data communication network. The DCN, of course, this is, remember, once you have installed a router somewhere, you need to be able to manage this router. So the data communication network, of course, it's a very critical part of the network. If you are doing multicast in the network, you need IGMP, you need PIM. For the security, you need, or if you have VPNs, definitely you will have IPsec. I've mentioned segment routing. We have bidirectional forwarding detection, BFD, for quick detection of link failures. So when you have a ring setup and you need to be able to quickly detect link or node failures, that is where we'll be having BFD, bidirectional forwarding detection. And then we have VRRP for the redundancy, the link redundancy, that if you have multiple gateways, you can configure VRRP in the network, and then you will have a redundant gateway for the services from different customers. So this is just an overview, just a summary of which protocols we expect to discuss in our upcoming episodes. I've mentioned that we'll be having separate session for IGP, ISIS or SPF, and then we'll have a separate session for BGP, BGP, and then we can also discuss about MPLS, LDP, and segment routing. Any question on this? The choice of the network always depends on many other factors. You will find some other service provider, they are using OSPF, some are using
Brother
ISIS.
Martin?
Yes.
Yeah, sorry. The time you said any question about what you mentioned earlier on, I was okay. I have a question. It's about the VRRP.
Yes.
So this one, it is specific for one vendor. It is a standard.
It's the industry standard. Fast low
Okay.
redundancy protocol, yes.
So any equipment, any vendor can implement
Yes.
VRRP.
Yes.
Okay, that is just for redundancy between nodes. If one fails, then the other one can take over, right?
Yes.
Okay.
And finally, the future of IPRAN. So of course, IPRAN is evolving with the coming in of 5G, the cloud computing, and even we are now talking of 6G. We also need to think about the future of IPRAN. So some of the key highlights that we are talking about are, we have network slicing. Of course, this one I will not go into details, but we have network slicing, we have iFit, we have telemetry, we have SRv6, and then you can also see in terms of capacity. We only had 1G connections, now we are doing 10G connection or even 25G connection to the BTS, so that we can accommodate the higher capacity that is being pushed from the customer. The access rings, we are now moving to 50G, even 100G. Remember, we used to have 1G or 10G, it will be enough. With the 5G, 6G, we now need to consider higher capacity access rings for our network. And even the aggregation now, we need much higher capacity. 100G, definitely not enough, even now in many of the networks. So these are just some of the things. Of course, we have the Open RAN. When we talk of Open RAN, the ORAN, we have mentioned about the SRAN. You now don't need to have 3 or 4 connections for different access technologies. Just one connection, that is enough for your different access technologies. So the network will be evolving to 5G and even 6G. I'm sure many of the networks are already having 5G in place. So yeah, there are something that we need to consider to ensure that the network will also evolve. The IPRA network will also evolve. We have the SDN. You can see here we have the SDN controller. So yeah, we don't need to continue doing everything manually. We need to talk about the network automation and many other things that needs to be in place for the evolution of the IPRAN network. Of course, this one I've just given a high overview of it. And yes, that is that is it for my presentation. We can now handle some few questions from the
Yes, Brother
audience.
Martin.
Yes.
Okay. The VRRP, it is on layer one redundancy.
No, no, no. That is why you say it's a layer one.
Like if one link fails and a fiber link is down, and it can be done like automatically, or it is when one device fails or something like that.
It could be a link failure, it could be a node failure. It should be able to switch from the master to the backup, and then yeah, because VRRP will
Okay,
have the
okay,
preemption. Once the primary is down, the secondary should be able to pick up and carry the traffic. So it could be a link, it could be
okay,
a node. It depends on how you've implemented it.
okay. And it can be implemented in CSG ring or ASG.
No, many times when we talk of VRP, you see, especially at this point of connection, when we are connecting to the controllers, this is the most common place you will find us configuring the VRRP so that we have multiple gateway for the traffic coming in from the controllers.
Okay,
This one, many
okay,
times in the access ring, we are using BFD, and many other applications that can be used in the transmission network to achieve redundant. Is that
okay.
clear?
Thank you.
I saw someone was raising hand. Just proceed, unmute and ask your question.
Hello, Martin.
Yes,
Yeah, I I want to bring out a scenario.
yes,
There was a time in a real network
yes,
where there is a power outage and it affects different sites that goes through a microwave and
yes,
comes back to the IPRAN gateway.
yes.
So is there a solution wherein we can implement VRP on the access side?
Yes, if you have, you see, the reason that we need, the moment you have two connections, then you can do VRP, right? If, for example, you are having two connection from these, maybe you have two CSGs at site, and you
Okay.
can do multiple connection. If the BTS allows you to do multiple connection from the BTS to do different devices, then yeah, you can go ahead and implement VRRP. Because this one is just implementing the gateway redundancy, right?
Yes.
Yeah, so it
No,
depends on the setup.
what I mean, it goes through the microwave because the microwave serves as the transmission medium to the remote site.
Yes,
Because we can use one interface, for some like 10 or 15 LAN sites, and that one must go through different microwave, but it can pass through the first IDU and then goes inside so that it can reach other side. So if that gateway goes down,
yes,
that's what I'm saying. That gateway goes down. Let's say a particular IPRAN that serves plenty remote regions
yes,
sites, then goes down due to power and a continuous power outage that's happening on the site.
yes.
So can this scenario help in such a way wherein you have two optical fiber coming straight to it to the microwave and then separating to different sites?
Okay, you see microwave many times it's a layer 2, right? Where you just have
Yes.
VLANs, pass VLANs, and then if it's layer 3, like if you're implementing layer 3, then it's possible because you can have these connections.
Okay, maybe you can create some interface and
Yes,
then
yes,
different.
kind of. And then you deploy the VRRP.
Okay.
Yeah, but if it's just layer 2, you are passing VLANs like a switch, then you see you don't have much of options. But of course, yeah, we can see the real scenario that you're talking about, maybe in a separate session, and then yeah, we can see if we have options. We can engage separately on that and then see if we really have an option for it. Is that okay?
Okay, okay, no problem.
Okay.
Anytime you like. Okay.
So, Brother Martin,
Yes.
Hi, dear Martin.
yeah, just my last question. Okay, the brother can go first.
Okay. I just want to give you a suggestion that for beginners, it is almost difficult that from as we want to learn IPRN technologies. So from where we start and we will end it here. So from your YouTube channel, I saw the playlist of IPRN technologies, but the videos are not in an order, so that a beginner should think that from where I will start and where I need to watch the new videos or the next videos. So it will be good if you give us a flow chart or something else, so we will have a good understanding of it.
Okay, that is well noted. I will work on it.
Okay.
Thank you. Or you wanted the question to be answered right now? Maybe I didn't. Yeah, but of course, IPRAN is an application. You see, that is already an application layer. So and it's mainly based on IP. So if you are looking into understanding the IPRAN technology and even doing the deployment, of course, definitely you will have to understand the protocols first, the basic operation of the protocols like the OSPF, ISIS, and even the other things. And once now you have understood the basic, that's when you will now move to the second stage of trying to now start designing the IPRAN network based on the knowledge you have for IGPs, for BGP, because before you deploy BGP, definitely you have to understand how BGP operates. Then now you can pick the best practices of BGP and deploy them on your IPRAN network. Same to ISIS, same to MPLS. So yeah, I can do a rearranging of the videos so that they are well arranged to help you in learning about the IPRAN. But if you have any question, feel free to reach out anytime and we can engage on one-on-one.
Okay, dear. Thank you.
Okay, next question. Abdul,
Brother Martin.
Yes, sir. Yes, sir. How are you?
I'm good, I'm
Thanks
good.
for this opportunity and all. Yes, I are getting me.
Yes, yes.
Yeah, I said thanks for the opportunity and all. I wanted to ask like this PDF. Yeah, been going this PDF note. If we can have it, like to further read.
Which one?
Hello.
Yes, yes.
I'm talking about the notes. This ones you did presentation. I'm talking like if we can have access to it also later for further reading.
For the video or the PPT?
Yeah, the PPT. Yes, the
Yeah,
PPT.
the PPT, if you registered, I think we have a WhatsApp group that we have been engaging. If someone
Okay,
has a
sir.
question, so if you have registered and you are part of that WhatsApp group, I think I will share the PPT in the WhatsApp group. And this is not the
Yeah,
last.
I'm part of it, sir.
Yes, yes. So I will just share in the chat, or I can even upload it on Google Drive and then share the link with the team so that they can download it.
Okay, sir. Thank you.
Okay, any other question?
Someone in the chat is asking if you can help him to share documentation of IP LAN of microtech equipment.
Uh, okay, I have interacted with deploying IPRAN equipments from Microtech. Anyone who has mic, Michael, maybe he has dropped, but yeah. I haven't really deployed MikroTik because MikroTik majorly they have been used on especially for the enterprise deployment. So I think we can discuss about it separately. Just ping me and then I can see how I can help on that.
Oh, Martin,
Yes.
can you hear me?
Yes, yes. Your camera is
Yes.
on
So
or
I wanted to ask. Yeah, I wanted to ask. My camera should not be on. I wanted to ask. Do you have the schedule for the upcoming classes? And
not
then
yet, but I
the
can
second
prepare.
thing,
Yes, yes.
yes, so if you prepare that and you can share. And then the second thing is,
Yes.
so I come more from the Cisco background, okay?
Yes.
So I was asking the way of designing the classes. Do you, or for your consultancy, right? For your company, do you have like labs or where we can lease and be able to practice and things like that to get like really the hands-on as we
Yes.
complement with the
Yes.
classes and the session? I try to look at your website, doesn't show anything like that, so I wanted to
Okay.
just
For the lab
figure out
that
someone
is
else might want to.
okay. Can I respond? You are through.
Yes, please.
First question about the other session. They will be communicated. You see, we are almost at the end of the year. So much going around. So let me see the schedule because I don't want to schedule it and then start postponing like we schedule. That's why I prefer to go session by session. Once I'm ready, I've confirmed that yes, this day I'm free and then I can share the notification maybe 2 weeks earlier and then we can meet again for another session. I don't want it to be fixed like we'll be having next month or next week. No, no, no. I prefer it to be flexible in a way that it allows me to attend to other things also. And also, I've said that before we have the session, I will communicate early enough so that, yes, you have time to prepare and also time to arrange your activities so that you can attend the session. So I can share the topics, but when they will be held, that one will be communicated as time goes. For the lab setup, that is something in progress. It will take time, but yeah, with time, it will also be communicated when the lab is ready. So for now, it's not ready. I'm just using my personal lab, but working on something. Is that clear?
Okay, no problem. Yes, it's clear. I think sharing the topics would be helpful. We can just wait for the schedule whenever you're ready.
Okay, okay.
And for the lab, whatever you're working on, we can lease, right? Like we can reserve and then maybe pay a fee and we can access and use it. Is that something that is what you're
Yes, yes,
working on, or it's different?
that is the model I'm looking at.
Okay. All
Yes.
right, no issue. Thank you.
Okay, any other question? Any other?
Yes, teacher.
Yes,
Hello.
yes. Yes,
When
please.
finish this course, when the finish this course, do we get the certificate of participation
No, no, no. This is just an interactive session for us to share
for
knowledge and
learning?
then yes,
For
yes.
learning.
If you want certification,
Yes.
of course,
Okay.
you can go for Cisco certifications, you can go for Huawei certifications, but this one there will be
Okay.
no
Okay.
certificates. It's just
Okay.
knowledge sharing. Yes,
Okay.
yes.
Okay. Okay. If we need to learn for the IPRAN, uh, 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 do you give the other sessions for IPRAN or for YouTube for lessons?
Yes, we have a YouTube channel. We have been publishing videos
Uh,
on IPRAN.
PPT
Oh, for the
on
PPT.
BBT lesson. Yes.
Yeah, the PPT can be
For
shared. I've mentioned that we have a WhatsApp group.
This session, this course, the last, all the sessions.
This is the
We
first
are.
session.
Yes, yes.
This is the first session, so we'll have subsequent sessions and we'll be sharing the materials. But this is our
Okay.
first session.
Okay, okay. Thank you. Thank you, teacher.
You're welcome.
Shukran.
Karibu. Any other question? Any other comment from any one of us before we close the session?
Yes, Brother Martin.
Yes.
Yeah, thank you. Th- Thank you so much for this training. I know it's a very big thing, a big thing that you have done to give your time and your knowledge to us. And thank you so much. Just one question before you go is I just want to get it once and for all.
Yes.
So the ring topology in IPRAN is just for gateway redundancy.
Yes. Primarily it's for gateway redundancy.
Okay.
Like
Okay.
you have multiple paths. Whenever you have a failure in one of the sides, you can still have your traffic switch to the other direction without any manual intervention.
Thank you.
Yes, so it's primarily for redundant connections and protecting the service. It will improve reliability.
Thank you.
Okay. Any other question? Final question? So I hope we have all enjoyed the session, and as we have mentioned, we have our YouTube channel, Life Technologies. You can log in and watch other videos. We have also lab simulations on Nokia, Huawei, and Juniper. So if you are interested, you can check our channel and have a look at the videos. If you have any question, feel free to reach out. And yeah, let's keep learning and sharing the knowledge that we have. And thank you so much for joining. Yes.
To Pascal Mahindu for the lead. Yeah, we much appreciate and hope we can join in the next session. Thanks. Yes.
Thank you. Thank you for joining. Thank you for joining. I appreciate your time, and so I know there is a lot, but yeah, you've also taken your time to join the session and also to participate. So yeah, let's keep in touch. If you have any question after this, you can. I hope you have the link for the WhatsApp group. You can join the WhatsApp group, and we'll